Hello, my name is Evdokia I represent the company Tyreman Group. I'm glad to welcome you in our living laboratory on industrial symbiosis development in St. Petersburg, Russian Federation. We majorly work with auto transport companies in Russian Federation and CIS countries. Our main clients are mining companies. Our team consists of 25 people. We also have an office in Siberia, the Kuznetsk Basin. Our key solution that is popular among our clients is the tire maintenance technology. This technology contains the whole cycle of tire usage, from correct choice, operation, repair, retread, and recycling. Besides, we are implementing information complexes such as special equipment and online tire monitoring systems. The foundation of our values is effective and rational resource usage. That's why, a couple of years ago, we became members of St. Petersburg Clean Tech Cluster for Urban Environment, with the aim of looking for new, interesting solutions that could be offered to our clients. Moreover, we're current residents of Business Incubator Ingria, and we're looking for exciting startups in green economics area. For more details on our company's work consult, our official website, tyreman.ru. We joined the project Baltic Industrial Symbiosis in August 2019. The idea of industrial symbiosis is that waste from one enterprise become the resource for another. We're saying, let's give waste new life. Find available resources for your production. As members of Baltic Industrial Symbiosis, or BIS as we call it, we are responsible for development of business opportunities. We have 4 activities that we've been fulfilling within the project. The first is about identification of business opportunities. We've been looking for companies that would like to participate in the project, become subject to screening of their preliminary and secondary resources, which they get during the production. We have found 15 companies, and we consider this number to be the most convenient for the connection of suitable resources, taking into account that we want to pay our utmost attention to each company. We were striving for finding the average appropriate number of companies so that it was possible to connect them successfully. We'd carried out about 15 screening sessions and carefully studied all 15 participants. Screening was done with the help of the tool that was provided by our partners from Kalundborg, Denmark. As a result, we had analyzed all the data and resources and organized matchmaking events that would unite compatible business partners. At first, it was supposed that we would hold the event as a conference, invite many people, and give presentations. However, our experience showed that it wasn't the most effective approach. Besides, the pandemic altered our plans. So we ended up arranging lots of little events. We invited companies to have face-to-face sessions. The interesting thing was that the companies preferred to meet on our territory instead of their partners, because we were those neutral mediators who were only interested in the successful outcome for both the participants of the meeting and nothing else. In total, within this activity, we've held 7 matchmaking events, where people discussed possibilities of new symbiotic chains creation. In terms of LivingLab operations, we continued these activities and the frequency of meetings grew. In addition, we arranged excursions telling people about what had been achieved and what was to be achieved in the future. The project also provided an exchange peer-to-peer program between industrial symbiosis managers. We were glad to visit our colleagues in Norway and Denmark and learn how they were fulfilling the project, communicating with other companies, what results they had achieved, and what plans they had. Today, we're talking to you online. As part of the project, we have offered our own activity. It's a creation of a living lab as a place for practical testing of the industrial symbiosis and making industrial symbiosis concept more popular in our region. Furthermore, in our LivingLab, we conduct technical analysis on possibilities of building new chains. We also delegate some of the tests to other laboratories that focus on particular details necessary for us. Apart from technical evaluation, we carry out economic effectiveness evaluation of building new chains. Currently, we are creating green business model based on one of the streams that we're testing in our laboratory. We've decided to concentrate on used coffee grounds from our partner Boucher that produce a lot of the substance in our city. Therefore, in terms of creating a new green business model, we are working on the question how this resource may be effectively used for launching a new startup in our region. The LivingLab is a physical space that is located in Telmina Village, Tozninsky District. When choosing the suitable place for the LivingLab, we paid attention to our members' location so that the resource's transportation was convenient for all of us. The LivingLab consists of 4 areas. The first one is production and warehouse. In order to do practical tests, we needed huge amounts of resources. However, our partners were not ready to provide us necessary volumes, but mostly small deliveries. That's why we take their secondary resources and store their materials here. Then we save the necessary quantity and hand them over to testing or production where it's wanted. Besides, in the LivingLab, we have a co-working area for participants, so they can hold meetings here and discuss new ideas. We also offer a presentation area with Eco-Lectorium, where we host our events and demonstration area. The demonstration zone is an essential attribute of our excursions. We show how waste is turned into new resources, how it gains a second life. As a result of the project, we have identified 5 steps for building a symbiotic chain. The first is company screening. It is crucial to talk to the companies willing to take part in the industrial symbiosis development, and therefore determine the income of first resources and the outcome of secondary resources that they have. Next step is to build resources database and analyze it. The database will become the foundation for further theories on building new possible chains. The database is essential for arranging matchmaking events, as it serves for connecting the companies that are compatible in terms of resource type, stream, and the potential of the collaboration becomes vivid. Then goes practical testing of the idea. No business is built on its own. Tests, practical tests, are very important. They are first steps towards increasing the amount of production. We get the results that leads us to understanding of whether our idea worked out or not, whether secondary resource usage is actually possible and effective. The last step is building and start of the industrial symbiosis chain that we invented initially. Afterwards, the work continues and the chain is analyzed. New theories on how the chain can be improved are created and tested. Who are these 15 companies that agreed to participate in Baltic industrial symbiosis? It's a group of Danone companies in Russia. We work with their office in St. Petersburg. Danone makes milk products like yogurts, milk, etc. It's a group of Fazer companies that produce bread and pastries. It's Munhill Brewing Factory, Creative Touristic Outdoor Food Production, Niva Torf Production and Selling of Soil and Fertilizers, Corel Pre-Wrote Resource Crushed Stone Production in Karelia, and Grand Canyon Shopping Center. Biotechnology company BioCAD, Green Engineering company Enviro, 99 Recycle, recycled plastic production of accessories and interior elements, Eco-Factory Umnaya Srida, ecological furniture production, Boucher Coffee Chain in St. Petersburg and Moscow, Severnia Krevetka, plant manufacturing of life seafood, Tozninsky Mixed Feed Factory, and meat processing plant Tozninsky. In the LivingLab, we test various resource streams. The first is used coffee grounds. Our partner, Boucher, generate a suitable amount of used coffee grounds, and we are trying to figure out how it can be used. The first thing that we started testing was the creation of fuel coffee briquette. We bought coffee briquettes from the USA, gave them to laboratories, and made conclusions about their ability to transmit warmth and how much coffee grounds there was left. Plus, we estimated whether such briquettes would be competitive alongside the alternatives. As it turns out, it's a very effective technology that could be developed further. We found new partners, a roof company that specializes on briquette production, and we gave them used coffee grounds for tests. The test was partly successful, as we received a briquette, but it couldn't hold the right shape and crumbled. We need something to keep briquettes in the proper shape. Currently, we're discussing new testings and a search for the appropriate substance to solve the problem. Why are we interested in creating coffee briquettes? Because both LivingLab and our partner Severnaya Krevetka are using pellet boilers. Replacing wood pellet with a more ecological and cost-efficient alternative would be profitable for both of us. The second solution known to the market is creating reusable tableware from used coffee grounds to be used for hot drinks. We are currently researching what polymers are needed to create such tableware. It's in demand, so we're trying to work out a plan for implementing this production in our region. The third process that we're testing is used coffee grounds usage in mixed feeds. Our partner, Tosninsky Mixed Feed Factory, is ready to test used coffee grounds that is produced in Boucher. Boucher has also food waste that Tosninsky Mixed Feed Factory is ready to test for usage in mixed feed. Also, our partner Neva Torf produces a waste such as peat dust. It's an upper layer of soil in digested roots. Neva Torf doesn't need it for soil and subsoil, so they're ready to give it away as a resource. Used coffee grounds are also used in America and Europe for growing mushrooms, which we found very interesting. We thought, as we had such lovely secondary resources as peat dust and used coffee grounds, we decided to add sawdust to this combination. Now, oyster mushroom is being grown in our greenhouse inside the LivingLab. For mushroom cultivation, we test various substrates, add used coffee grounds in different proportions, peat dust, and other secondary resources. We are looking for the most efficient substrate that would have a good combination with mushrooms. In terms of the project, we're building a green model that would show the product's potential popularity in the market. We've talked to the company Helsini from Helsinki, Finland, that is occupied with the same activity. They release their product in restaurants, taking used coffee grounds and giving mushrooms in return. Also, they've released a product on creation of a kit that can be taken home for mixing substrate, fungal mycelium, and grow mushrooms at home. During the research, we're testing different substrate mixtures. We add used coffee grounds, peat dust, sawdust. We aim at testing various secondary resources in order to find the best combination for mushrooms. In LivingLab, we are also trying a vermicomposting technology. Our partners produce brewer's grains, we have peat dust, so we want to mix these organic residuals to get a useful recycled biocompost. Our partners, Srida, make products using sand and plastic. Other project member has gravel sand as secondary resource. We thought, why not replace sand with gravel sand that our partner doesn't need? Srida are testing the possibility of this replacement in their current technology. We've been getting good results so far. Apart from that, our partners purchase plastic from plastic processing companies for usage in their technology. We are eager to find companies that have it as waste and that are ready to give it away to them directly. Another company, 99 Recycle, produces various accessories, interior objects from secondary plastic. For our lab's decoration, we used their panels. During the negotiation, textile covers were found in our production. They were left after the previous project without further usage. We used to cover tires and wheels with these covers, and 99 Recycles took them with pleasure and used the covers for sewing pillows. The pillows were filled with secondary textile that is handed in by St. Petersburg dwellers. People hand in their old clothes because they're out of fashion or just worn off. The clothes are collected in special parcel lockers called Spasibo, equal thank you. Then, these clothes are recycled and directed to pillow production. For instance, one of our partners, Nivator, uses stretch film for covering their pit, and afterwards it's not needed, and they don't know what to do with it. So, we took this stretch film and gave it to Umnia Srida for testing. Likewise, 99 Recycle in their sewing sector produced textile rolls from shopping bags. So we're discussing with them what else could be implemented there. For example, now we're considering the usage of PPE, masks, medical gowns that are widely used by our partners in their production and due to the pandemic situation by general public as well. We have announced a research challenge with our partner ITMO University. The topic is about ways of using secondary resource provided by meat processing factory Tozaninsky. They are our partners too, and they offered pig blood for the occasion. We want to find an innovative and effective solution to how this secondary resource may be used so that it is not wasted. We accept applications from students and aspirants, and then we will choose the best solution that will be granted money for further research. In addition, we're planning to implement separate waste collection with Grand Canyon Shopping Mall. They are ready for new eco-initiatives, but their idea is to start changes internally with implementing the system in their production and marketplaces. Also, we carried out a research with Tozaninsky Mixed Feed Factory on secondary resource of brewing factory Munhil, which is water with barm. We explored the possibilities of using that protein-rich resource as a feed supplement. The research was successful, and the companies are now looking for ways of further effective collaborations. Unfortunately, not all of our researches are successful. For example, we carried out a research of milk whey produced by Danone, and our partner Tozaninsky Mixed Feed Factory took it for testing. As it turned out, they failed to find enough healthy substances that could be used in feeds. But we will continue working on this question. We're open to new collaborations. Perhaps your ideas will help us build a new symbiotic chain. When we started this project, we were surprised at how many people responded to us, how many companies were ready to take part, and how the region actively supported our policy of stable economic development. Our international partners helped us a lot. They shared successful cases and ideas on building new symbiotic chains. We learned a lot from their experience. We consider the key factors of our successful development of the LivingLab to be the active position of our members, international support, and motivated team of Tyreman Group. We hope that as a result of the project, we will be able to build new symbiotic chains, inspire productions with new way of thinking. We expect that the project consortium will cooperate further, and the project will both prosper in our region and develop in other regions of the Russian Federation. Thank you for your attention. I'm Evdokia Lamangana, Living Laboratory, St. Petersburg.